Hi, how are you? Many of you have encountered cracks in solder joints on print circuit boards, especially on through-hole deep components. A PCB may operate for years and then suddenly fail because of cracks in solder joints. In this video, I will explain why solder joints cracks over time and what combination of factors leads to this. I will also explain how to reduce the probability of cracks in solder joints if you are involved in electronics design, manufacturing, or PCB repair. Let's start from vibrations. Absolutely everything vibrates in our world. And in the context of soldering and printed circuit board reliability, vibrations have a very clear significance. Electronic devices are used almost everywhere and are constantly exposed to vibrations, dynamic loads, impacts, and mechanical deformation. Over time, vibrations weaken solder joints, especially in through-hole components, where mechanical flexibility is present. Metals in the soldered area gradually lose bonding strength, and sooner or later a crack can form in the solder joints. In industrial electronics, the effects of vibration on component movement are reduced by fixing the component body with adhesive at 3 or 4 points, or on the heavy SMD component. The vibration experienced by solder joints are closely related to the next factor: component weight and miniaturization. The smaller the electronic component, the lower the mechanical load on the solder joint. That's the rule. I understand that it is not always possible to replace large film capacitors to compact SMD capacitors. However, during PCB design, it makes sense, whenever possible, to look for solutions that allow the use of smaller SMD components instead of massive through-hole deep components. Component weight directly affects the level of mechanical stress, sensitivity to vibrations, and long-term solder joints fatigue. The next factor is current and high voltage. The currents and high voltages passing through the soldered metal have a significant impact on the durability of solder joints. At the solder joint, three different materials are present at once: the component lead metal, PCB copper, and the solder alloy. These materials have different densities, structures, and physical properties. During long-term operation under electrical load, electrical and thermal effects accelerate joint degradation, especially when combined with other factors. The current and high voltages are not the only cause, but it is an important part of the overall picture. By the way, thank you for watching this video. Support this video with your like and subscription. And the next cause is soldering quality and solder alloy. Soldering quality directly affects the reliability of solder joints. Insufficient soldering volume, small fillets, pores and voids inside the soldering joints reduces the mechanical strength of the solder joints. Solder quality also matters. Using solders from reliable manufacturers reduces the likelihoods of hidden defects and unstable PCB behaviors over time. Even the design of PCB pads plays a role. Insufficient pad size for high currents or voltages can become an additional source for cracks formation, in combination with previously mentioned factors. And right now, next factor: flux and soldering temperature. Flux has a major influence on solder joint quality, as a standalone flux and as a part of solder wire. High-quality flux and properly selected soldering temperature ensure good wetting and flow of molten alloy. Also allow solder to fill micro voids, also reduce of micro defects in the solder joints. I have a separate video dedicated to soldering temperatures, soldering iron tip temperatures, what is the soldering flux. You will find links in the description. Watch later. And I move on to the next cause: external temperature fluctuations. Sharp and cyclic temperature changes significantly reduce the shelf life of electronics. Different metals have different coefficient of thermal expansion, and this is especially important in solder joints. Pause the video and look at the table of thermal expansion coefficient of metal most commonly used in electronics. Even in the range from 0 to 100 degrees of the Celsius, their ranges are very different. Example 1. When heated, copper with a thermal expansion coefficient 16.6 and tin with a coefficient of 23.4 expand differently. This creates internal stresses that can lead to microcracks over time. Example 2. An aluminum component lead soldered with leaded alloy forms a joint with different expansion coefficient, increasing the risk of cracking. At the interface between solder and metal, stress occurs during overheating and cooling cycle, and one material always expands slightly more than the other. All factors: vibrations, component weight, electrical load, soldering quality, soldering materials, and temperature fluctuations work together, not separately. Design your PCBs with the thermal and mechanical properties of materials in mind. The smaller the electronic component, the lower the impact of thermal expansion and vibration. For large and heavily loaded components, a different strategy is used: improving component quality, proper fixation, and correct selection of soldering materials. I hope this video was useful for you. Like this video and subscribe to the channel. Write in the comments what soldering problems you have encountered in practice. In the description, you will find links to my Instagram and Telegram. Support my channel on Patreon. In the description, you will also find links to soldering Flux's diamond flux for electronics PCBs. Thank you for watching. See you next video.